Rahim. This is Engineer Masood Sarkani, and today we have the technical session number 137. Our topic today is bearing capacity of the ground or the soil and also the construction area. So I would like to request you to like it, plus it, subscribe the subscribe the video, and in order to reach the next video with the easy access. So our channel reference is Material Engineer Official. So all these construction issues are discussed in accordance to the quality assurance and the quality control purposes. So we will go about the topic. Uh, what is the bearing capacity? Bearing capacity is a soil is a maximum load per unit area. So this is the ultimate bearing capacity of soil shown in a table, dividing the ultimate soil bearing capacity by the safety factor, where we get the maximum safe bearing capacity for the soil and the design foundation. So the bearing capacity will use different types of the soil such as clay, sand, gravel, rocks, etc. Following tables also is for the bearing capacity details, the different values of the bearing capacity under the application journal shear failure values are shown, where the NC, NP, and the NY are the factors to describe the bearing capacity values. So the following bearing rocks have the different bearing capacity. Hard rock is 330 ton per meter square, or 3,240 kilonewton per meter square. Uh, Laminated rocks 165 ton to per meter square, or 1,620 kilonewton per meter square. Residual deposits of the shattered and the broken rocks are the 90 ton per meter square to the 880 kilonewton per meter square. Soft rock 45 tons per meter square, or 440 kilonewton per meter square. So non-corrosive soils, sand, gravels are the which are the compactable. So it's 45 tons per meter square to 440 kilonewton per meter square. So the compact dry coarse 45 ton to the uh, 45 ton per meter square, or the 440 kilonewton per meter square. Compact, dry, medium, and the sand 25 ton per meter square to 245 kilonewton per meter square. So final sand 15 ton per cubic meter, per meter square, or the 1000 or the 150 kilonewton per meter square. Loose gravel or the sand 25 ton per meter square, or the 245 kilonewton per meter square. Loose and the dry fine sand 10 ton per meter square, or the 100 kilonewton per meter square. So corrosive soil also the hard or the stiff rock soft shell 45 ton per meter square to 445 kilonewton per meter square. So medium clay 25 ton to 25 ton per meter square to 245 kilonewton per meter square. Moisture clay, sand, and dry mix 15 ton per meter square, or 150 kilonewton per meter square. Soft soil 10 ton per meter square, or 100 kilonewton per meter square. Very soft soil 5 ton per meter square, or the 50 kilonewton per meter square. Black cotton soil peat by the soil investigation is the different states like this. So generally the fields or the soil system are recognized and studied according to the classification and the sub-classification of the soil, and the where it exists and what are the property of the soil, and according to the study of the bearing capacity how much the contamination required for the mixing of soils and in order to make the soil is heavier than the original properties and the original characteristic of the soils. So this we can analyze and we can judge and we can recommend the design criteria in order to get the achievable parameters which are existing on the specification and the area geology and the strategy of the projects and the bearing load of the buildings calculation. So bearing capacity value of the different types of the soil clay is 100 kilonewton per square meter, sand is 400 kilonewton per square meter, gravel is 300 kilonewton per square meter, rock is 3240 kilonewton per square meter. So different SBC are the following. Bedrock is 574 kPa. So gravel is 250 kPa. Sedimentary rock is 190 kPa. Sand gravel is 140 kPa. Sand silt clay sand are 95 kPa. Clay sand clay silts clay are 70 kPa. Actual sites where we conduct the several tests and SPC are the recommended value bearing capacity for the preliminary analysis. So the types of the rocks of the soil of the bearing capacity also in kilonewton per meter square or kg per centimeter square. So rocks have the hard without lamination of the defects and the example granite trap and the diorite uh, 3300.33. So laminated rocks are also the example of the sound consolidation and where the properties are checked and then its recommendation is takes place. So residual rocks also shattered and the broken beds also and cementitious material also and soft rocks also for 50. So non-corrosive soil also the gravel and the gravel mixture and the compact the bearing high residential or the penetration of the executed soil. This also is a great study. Coarse sand and the impact dry sand and with the greater than the foundation below and footings and the medium sand compact and also final sand silt and dry lumps easily dissolvable and also loose gravel sand gravel mixture. Also all of these types are need to be studied and according to the data it should be derived and then the design calculation and the design recommendation to be is suggested. So the Kusi soil, also the soft, hard, and the stiff clay, deep, dry bed, medium clay, rapidly, and the master clay and the sand clay mixture, and also the soft clay, and also the black cotton, and all of these parameters should be studied and is uh, compiled in the report and the recommendation takes place. So calculation of the bearing capacity is a soil if there are many theories, but all of these theories are separated in accordance to the uh, uh, technical data collecting from the particular sites and the, some assumption takes place and also the design of the footing and the design of the raft and recommendation of the piles and whatsoever and the heavy structure coming on the uh, road area, infrastructure area like the bridges and the thrust block and other uh, anchors which are costed on the ground. So it's depend upon the strategy of the planets and the nature of the sites also. So the bearing capacity calculation also numerically it can be calculated and also the report can be prepared and all the data should be considered in accordance to the uh, relevant standard and the international highway codes and whatsoever it is, and the foundation engineering. So all of this bearing capacity is very, very necessary for the design parameters and the design study. So soil plays a important pouring footing and also make sure that it can be carried load by the proper standards which is relevant to the technical study, and also the footing of the design and also the uh, soil bearing characteristics. It should be uh, included in the report by the numerically and the by graphically and also by 3D probing. So this was the briefing about the bearing capacity, s- and we will discuss in next video with another subject for new over technical session. So thank you very much and have a nice day. So the bearing capacity is mostly it is a major factor for uh, the design study and the heavy structure coming on the area where the construction is going on.